This video is part 3 of my series of how to make your own DeWalt airlock replacement. In the previous 2 videos, I showed you how to make the hose thread and how to modify Allen DeRucher's inlet end. Now it's time to assemble the part. I'm going to make 3 versions. One with a small hose for the DeWalt dust extractor and small shop vacs. One for a large shop vac hose, the normal 2.5 inch that you probably have in your own shop vac. And finally, the small hose with a remote control bracket. Before I get into the assembly, I ought to answer a simple question you might have. Why am I even making these? The DeWalt version can be bought for under $10, so it's not to save money. I actually have 3 reasons to make my own quick connectors. The first reason is the DeWalt fit. Almost all the newer DeWalt tools come with the airlock dust connection style. However, their own airlock quick connector doesn't actually fit very well with some of these, as you can see here. Allen DeRucher's locking system and my own adapters fit much better while still airtight, and they lock securely. The second reason I made these quick connectors is that you cannot buy any that fits hoses other than those sized like the DeWalt dust collector hoses. As you saw in the first of these videos, I can make the quick connectors fit almost any shop vac hose. The third reason for making your own is to get rid of that awful Velcro strap on the DeWalt dust collector remote. This is where I like the remote, right on the hose quick connector. Back to the assembly. Let's look at each part. The inner lock ring is from the original design, and so is the outer lock ring. I have not modified either one, I'm just using the originals from DeRucher's design. Next is the airlock inlet I modified in the second video, and the hose thread in the first video. Both were made in 2 sizes. The remote bracket is a derivative of the screw-on bracket I made some time ago. It's only useful if you use the dust collector remote. I prefer making my designs modular, as it makes it much easier to modify the items as my needs change. But assembling parts does come with some issues that I promised in a previous video to cover. To avoid confusion, I'll show you how to make 3D printable parts before getting into the problems you can encounter with modular design. Therefore, I will start by showing you an easy way to join the parts into an STL file. Next, I will show you a couple of printing tips to get a perfect print of the quick connector. Third, I will get into the errors you can encounter when assembling modules in Fusion. I decided to make this a separate video. Last, I will show you briefly how to make the other 2 quick connectors. Let's get into Fusion to make the first quick connector. Open Fusion and open the data panel in the folder where you have the module files. Drag the airlock inlet small vac hose module into the canvas. This creates a link component that is ground to the parent. We'll leave that as is. Now drag the shop vac M40 hose threads into the canvas. It's located at the origin point just like the inlet, so drag it up clear of the inlet. Both parts are now in your toolbar and a timeline showing as linked components. I made a shortcut for the align tool, Shift A, but you can just click modify align if you don't have a shortcut set up. Rotate the view, then hover over the base of the thread component and click Control to find the center. Click on the center. Rotate again and do the same thing to the inlet base. Click Capture Position. Now I want to add some ribbing to make it easier to thread the connector to the vacuum hose. I need to make a construction plane 35 millimeters from the base of the thread component. Click on Construct, hover over the base and drag it up 35 millimeters. Press P for Project. Select the new plane for that projection and make sure the plane is visible. Click on the base of the thread component so the circumference is projected. Make the components invisible and select the top view. While still in sketch mode, click C for circle, then center the circle on the 90-degree point on the outer perimeter. And we'll use 5 millimeters. Finish the sketch and make the components visible again. This makes it easier. Rotate the view and turn off the construction visibility again. Select the half circle on the exterior of the thread component. Press E for extrude. Ideally, I would want to extrude to object, namely the inlet base. But since these are separate and linked components, this won't work. So select all. This won't interfere with anything, so in this case that is okay. Now press F for fillet. Select the top of the new rib. Use half the rib diameter, so 2.5 millimeters. Now select the rectangular pattern. Choose circular pattern. Choose features and select the rib as well as the fillet. Click on the perimeter as the axis. Change the quantity to 8. Verify the distribution is full and then click OK. Go to Home View. And now let's make it look nice. Press A for Appearance. Select whatever appearance type and color you like. I have a saved profile for my blue PETG high flow filament. Oops, I need to select everything first. Start again. Select the whole thing. Press A again and drag the selected appearance to the components. And they will all look the same now. Time to save the project. Control S for save. I will call this Airlock Assembled and click Save. It's tempting to combine the whole thing now. Don't. It will cause problems. I will show you those problems in a separate video that's linked below. Instead, I will export the file as an STL file, and that will combine the parts in itself. Select the folder where you want the STL file. Once you have exported the file, the basic airlock quick connector is now done and ready for printing. This brings me to the print tips I promised. I have printed dozens of test files with different materials and found some favorite choices and settings. First of all, if your print slicer allows multiple print plates, I recommend getting all your objects organized in one place. Here are the original lug rings imported from DeWalt's posting. Next, the small airlock connector we just made. I also have the large thread connector as well as the small airlock with remote bracket. I will show you briefly how those are made at the end of this video. Make sure you name the plates. It's much easier to keep things organized that way. My second printer tip is to switch to a 0.6 millimeter print nozzle. They're cheap, easy to replace, and they print in about 2/3 the time, since they deliver 50% more plastic than the standard 0.4 millimeter nozzle. I used that 0.4 millimeter nozzle for more than a year, as I was concerned about print details. Turns out this was completely unwarranted. I printed countless items with the larger nozzle and had no issues. Even when printing desiccant boxes with a fine grid, that nozzle worked okay. Let's look at the time saved on one of these prints. I'll use the airlock with the bracket. As you can see here, the print time for the 0.6 nozzle is 3 hours and 6 minutes versus 4 hours and 55 minutes for the 0.4 millimeter size, which means the larger nozzle saves 1 hour and 49 minutes, or 37% of the print time. For filament material, I have tried ABS, PLA, and my new favorite, PETG High Flow. With the PETG, I've been able to use a standard 15% infill and 3 walls. This PETG prints much better than previous PETG filaments and just as fast as PLA. I highly recommend it. Let's get into the settings. If you use the PETG High Flow, there are not a lot of changes needed. In the quality tab, I recommend Arachne wall generator. It is stronger and does print faster in some instances. In the strength tab, I recommend 3 wall loops and gyroid infill. You can use a higher infill percentage if you're worried about the strength. I've had no problem with 15%. Leave the speed tab alone. You will need support for this print. I use the 3 support auto, 3 slim, and the threshold set to 10% worked great for this one. It will be very difficult to remove the supports unless you use a different support material. The beauty of the PETG is that you can use regular PLA. I covered this subject in one of my previous videos. Links to that and all the other items mentioned in this video in the description below. For even greater ease of removal, increase the top and bottom C distance. This generates a thicker layer of support material. I used 0.3 millimeters. That's it. I found these settings worked well for all the parts of this print. Take a look here. We don't want support for the thread, but we do want support for the overhangs. Oops, one more item. I found that supports are not actually needed for the lock rings in spite of the slicer warnings. However, I did add inner brims. Choose the object process to avoid changing the other print plate settings. Alright, I'm going to print all the pieces and assemble it all. The version with the remote bracket has the most parts, so I will show you the assembly of that version. PLA support material makes it pretty easy to remove the supports. Had I not used the PLA, but just the PETG material, I don't think I would have gotten these areas clean. lock rings, I add just a few drops of epoxy glue. I use JB Weld Clear Weld, which is for plastic. It works really well. For PET and PLA, you can also use super glue or CA glue. Make sure you only put a few drops in. You don't want everything to get stuck together. The outer ring needs to be able to rotate. Make sure the outer ring is flush with the inner ring. If not, flip the outer ring 180 degrees. You can use a clamp or a vise to press them together, but it's not really necessary. The quick connector is now ready to use. If you want to explore some of the errors you can encounter when assembling modules in Fusion, please see the short video I posted. I'm using this project in that video. Now let me show you how to make the other two versions. This is quite simple. Starting with the large hose thread size, it's made the same way, except for using the large inlet and the 50mm hose thread I created in the first two videos. Additionally, the exterior ribs that makes hand threading easier should be a 3mm diameter instead of 5mm. Here's a quick assembly video. As for the version with remote control bracket, it's based on the first version we made. Open the assembled airlock file. Right-click on the circular pattern and select Edit Circular Pattern. Click on Suppression and deselect the 3 ribs on the back side, and then click OK. Next, drag in the bracket platform. It will be added as another link component. I made a previous video on the bracket as a screw-on bracket. This is merely a modified version of that. I am not going to cover that in this video. The bracket needs to be rotated around 2 of the axes by 180 degrees each. Then drag the bracket to the back side of the airlock. Now position the bracket to leave enough room for zip ties on both ends. That will be near the top edge. Select a line, and then to align the parts, select the back side of the bracket and the outside of the airlock. Click OK or hit Enter. To add strength and remove the sharp edges, extrude the 2 sides of the bracket, E for extrude, extrude to the surface of the airlock, and you're pretty much done. Save the file, export to an STL, and it's ready to print. If you're still with me, I'm impressed. This video got much longer than planned. As promised, I will have an upcoming video on how to assemble simple STL files right in Bamboo Studio. For now, thanks for watching and see you in the next video.